number one essential to making the basic straight line fly cast is that the rod tip must travel along a straight line. This is the basis of fly casting. All of the other essentials work together to achieve this goal. You must understand that the fly line does exactly what the rod tip does. Therefore, as the rod tip loads and unloads, the tip must travel as close to a straight line as possible. This makes perfect sense when you think about the rod tip traveling in a curve from side to side. Now let's watch what happens when the rod travels in a curved path. Watch the path that the tip of the rod takes. Notice that the loop forms a curve just as the path of the rod tip did. This is the proper way. Notice the rod tip is moving along a straight line. When first learning, the best way to prevent problems with this is to cast along a straight line such as a rope or crack in the concrete. By aiming down a particular line, the rod tip will instinctively track straight. Yet if the line does curve on its delivery, you will know exactly how the rod tip deviated from a straight line. It is a must to be able to make the rod tip track in a straight line. The same concept applies to the rod tip when traveling up and down. When the rod tip moves in a straight line, the top and bottom strands of the loop will be parallel and the energy of the loop will be directed straight at the target. This is possible by properly bending the rod and ending with a stop. The bend of the rod must progressively increase from the start of the casting stroke to the end. If too much or too little bend occurs, the rod tip will not travel along a straight line. When the rod tip leaves a straight line path, it will form a definite loop configuration that is the telltale sign of the problem. If the rod tip travels in a convex path, energy will be dispersed in several directions. Energy is directed up, out, and down. This pulls the loop apart and creates an inefficient, air-resistant loop. These loops are called fat or wide loops. Let's watch them in action. Notice how the loops seem to be pulled apart? It becomes hard to tell where the energy is directed. The rod first directs energy in an upward direction. Then some of the energy is directed straight at the target. And lastly, the rod directs the remaining energy down. These loops are not only air resistant, but only 1/3 of the energy is directed at the target. Now let's look at the correct tip path. Note the path of the rod tip as the rod gradually loads and unloads. It is very, very close to a straight line. Notice that the energy travels through the apex of the loop. This means that the majority of the energy is directed straight at the target. This is not true of a fat loop. On the other side of the coin, if the rod tip travels in a concave path, the energy from the rod directs the line in a downward direction and then redirects it in an upward direction. This causes the upper and lower strands of the line to cross. This configuration is called a tailing loop. Now let's watch. Notice the path of the rod tip. It first starts down and then back up. It travels in a concave path. Now this can happen in a couple of ways. First, the rod tip can load too soon or too much, and the tip will dip below the straight line. The second is the rod tip can travel in a straight line and prematurely unload. They both cause a concave path, resulting in a tailing loop. You must be able to recognize the tailing loop when you see it. We all throw them. You just don't want to throw that second one. Now let's look at a good loop. Notice again the path of the rod. See how the loop is directed straight down the same path as the tip of the rod? It helps to keep in mind that if done correctly, the front loop and the back loop will be 180 degrees apart. If the loops are over 180 degrees apart, you will be throwing fat loops. If they are less, you will be getting tailing loops. By learning these loop configurations, you will be able to diagnose most of the casting problems that will arise. It is a must to be able to adjust your casting based on the shape of the loop. So study these loops until you can recognize each loop and know what has caused it.